Problem 17, find the point or points, if any, of horizontal and or vertical tangent lines. So the first thing that I would like to do if I'm looking for tangent lines, I know that refers to the derivative. So I'm going to go ahead and take the derivative of this function. And I'll use implicit differentiation because I have x's and y's both happening in my problem. So the derivative of x squared will be 2x, and then plus the derivative of y squared will be 2y dy dx, because I'm taking the derivative of y with respect to x, and then minus the derivative of 3y will be 3 dy dx, and then equals the derivative of 9, since it's a constant, is 0. Okay, keep my dy's, dx's on one side and move my 2x. So I'll have 2y dy dx minus 3 dy dx equals negative 2x. Next thing I'll do is factor out a dy dx. So I'll have 2y minus 3 left, and then equals negative 2x. My last step is to divide both sides by the 2y minus 3. So my derivative is equal to negative 2x over 2y minus 3. Okay, so that wasn't even the question. The question was to see if there are any horizontal or vertical tangent lines. Okay, a horizontal tangent line would have a slope of 0. So if I'm looking for a horizontal tangent line, I'm looking for a derivative of 0. So to get a derivative of 0, I would actually set the numerator equal to 0. And solving for x, I would get x equals 0. Well, if you recall, it asks for a point, not just an x value. So I'm going to go up into the original equation and plug in 0 wherever I see an x. So we are going to have 0 squared, which is still 0, plus y squared minus 3y equals 9. And I actually, just FYI, hopefully you changed this on your practice test already, but I would like the problem to work out a little nicer. So we are going to, since we don't get to use our calculator, we're actually going to have it set equal to 10. And so this will equal 10 instead. And so now solving this, what I'm going to do is set this equation equal to 0. So I'm going to subtract 10 from both sides. So I'll have y squared minus 3y minus 10 is equal to 0. And then from there, I notice that this will factor into y minus 5 times the quantity y plus 2. And so I know that my y values will be y equal 5 and y equals negative 2. So I have horizontal tangents, and I have them at the points. My x value for both of them will be 0, so 0, 5, and 0, negative 2. All right, now going for the vertical tangents. I know vertical tangents would occur where the derivative or the slope is undefined, and that would happen when the denominator equals 0. So we'll set that denominator equal to 0. And if I solve that for y, I will end up getting y equals 3/2. Okay, and now from here it's just going to get a little messy, so just be patient here. Okay, so we know y equals 3/2, so now I'm going to go back up into my original equation and plug that 3/2 in for y. So I'm going to have x squared plus y squared, so 3/2 squared, minus 3 times y equals 10. Okay, now from here, we are just going to try to work this out, and we don't have a calculator. 3/2 squared means 3/2 times 3/2, which is equal to 9/4, and then minus 3 times 3/2 will be 9/2. This will still equal 10. Just combining like terms here, I'll get x squared plus 9/4 minus 9/2 would be really like 9/4 minus 18/4, so that's going to equal negative 9/4, and that will still equal 10. And so now I'm going to have x squared equals, I'm going to add 9/4 to both sides, keeping in mind that 10 is like 40/4. So if I do 40/4 plus 9/4, that will give me 49/4. And now to get rid of the square of something, I will square root it. So when I square root 49/4, I will actually get 7/2, but please keep in mind when we square root something, both the positive and negative answer would work. So I have vertical tangents occurring at the point 7/2, and the y value that went with that was 3/2, and the other place would be negative 7/2 and 3/2.